Okay, here's some more problems from the antiderivative worksheet. I had a little minor faux pas on one of my last videos here, so I'm kind of redoing it, so I'm just going to kind of use the work so I don't have to rewrite it all over again. Anyway, it's pretty straightforward at this stage of the game. Anyway, if we look at f of x, the antiderivative of this looks like this is going to be my log to the base formula. 1 over x looks like the antiderivative of the natural log of x, but if we got the natural log of 3 on the bottom, and that's probably log to the base 3 of x. There's another way to do this, and I'll kind of talk about that. But with the values that we have over here, with our initial value, so to speak, or our particular value in reality, it's going to be a little more conducive to log to the base 3 rather than the natural log. So, because this works out a little nicer with that. But both would work. All right, so this looks like this is going to be the antiderivative of this would be the natural log to the base 3 of x plus c, and you can always check it. What's the derivative of the log to the base 3 of x? What's 1 over x times natural log of 3? And the derivative of c is 0, so that checks out. See, no problem there. And then we put our values in, and that's why the 9 works, because that's going to work with a base 3. And so this is going to be f of x will be 3 when x is 9. So 3 log to the base 3 of 9 is c, and that's why this does work out so well, because this is the exponent that when I raise 3 to it, I get 9. 3 raised to what power is 9? 2, so this is 2. So 3 equals 2 plus c, which implies, if I subtract 2 from both sides, then 1 equals c. So there's your antiderivative with that particular value. Now the other way you could have done this is you could think of this just as a constant and bring it out in front. And then you take the antiderivative, and we have a constant in front of the antiderivative of 1 over x is the natural log of x plus c. And you can always check this out, because if you take the derivative, this is a constant, the derivative of the natural log of x is 1 over x. And the derivative of c is 0. So it's going to give you the same derivative. The only thing is that if we look at our particular value, f of x is going to be 3, when this is going to be the natural log of 9. And what's the natural log of 9? Well, that's not going to simplify so nicely. So this really wouldn't work out so well for that particular value. Okay, now let's take a look at the next one on number 34. And this is one of our straight derivative formulas. What's the derivative of the secant? Secant tangent. So the antiderivative of secant tangent is secant of x plus c. We can always check it. And then we know when x is pi over 3, f of x is 7. And the secant of pi over 3, well, the secant is 1 over the cosine. Pi over 3. The cosine of pi over 3 is 1/2. So 1 over 1/2 is 2, so this is just going to be 2. So 7 plus 2 is c, which implies that c equals 7 minus 2, which is 5. And there you go. And again, if for some reason I'm going a little bit too fast, then just pause it. Rewind a little bit, stop and think about it. That's a nice thing about this format. Okay, and then number 35. Cosecant squared, and this is another derivative formula. The antiderivative of the cosecant squared, well, the derivative of the cotangent is the cosecant squared. But only with a negative. Because the derivative of the cotangent is negative cosecant squared. So in other words, if we take the derivative of the cotangent, we get negative cosecant squared, but we want that, so we need to put a negative in. We want a positive, so we need to put a negative in front. So if we take the derivative of the cotangent, we get negative the cosecant squared times a negative makes a positive, so that's what we got, plus our c, and the derivative of c is 0. So if we take the derivative of this antiderivative, we should get f of x. And now we have our given values. So we know that f of x is 3 when x is pi over 6. Well, what's the cotangent of pi over 6? Well, the cotangent of pi over 6 is 1 over the tangent of pi over 6. I know the tangent of pi over 6 is 1 over the square root of 3, so 1 over the square root of 3 is just the square root of 3. So 3 equals negative the square root of 3 plus c. And that would imply, if I add that to both sides, that 3 plus equals c. So therefore, f of x equals negative cotangent of x, and then plus c, and c is plus 3 plus the square root of 3. Okay? So that makes sense.